Next up, we're going to hear from another university, but a little bit different. This is Hormel Institute at University of Minnesota, and Mr. Jeffrey McDonald, who is the director of IT there. And Jeff, you've got, I think, one of the most interesting devices out there when it comes to maybe I would call it machine-generated data, and that's the Cryo Electron Microscope, correct?
That's correct. Can you hear me okay, and can you see the screen?
Yeah, I hear you loud and clear, and we've got your slides.
All right, great.
So tell us a little bit more about Hormel Institute and what you guys are doing there.
Yeah, so well, I'm going to get into it a little bit in the talk here, but we are a research institute which is endowed by the Hormel Foundation. The Hormel Foundation was it was an organization created by the Hormel owners. Of course, the Hormel food processing plant is the world headquarters of Hormel. Hormel company is actually located here in Austin, Minnesota, and it was back in the 1940s they created an institute they created the foundation, and then they created an institute to study research, to research various things that were interesting to them. So when they first started, actually they were interested in how to best preserve food. So a lot of research funding went toward better ways to preserve food, and so on. And the institute was gifted to the University of Minnesota early on in the in the life of the institute. It was gifted to the University of Minnesota with some requirements that the institute stay locally in Austin, and so there it's just kind of flourished. And I'll go on one slide in a moment or two where we show that. But the institute now, what we're famous for now is our Cryo microscope, which is it's one of the few in the country. And I'll go into this a little bit, but the data, the data, electrons aren't going to get any smaller in the future, and therefore the data that is produced by the microscope, we expect to be valuable, well into the future. So the kind of unless there's some, I'm a physicist in my background, and so unless there's some new subatomic particle that they figure out how to do imaging with, electrons are going to be it. And the kind of improvements that you're going to see in the future, they're going to be based on higher data rates and better resolution, because you've taken so many images. And so the data that we have, we expect that data to be valuable on into the future. So so if I'll segue kind of into the talk now. What the discussion that I have here is how I've used Globus and Black Pearl and the ecosystem to protect that data from the Cryo microscope data. And so here's just a quick slide that kind of gives you a little bit of information about the institute from its beginning in 1942 with one lab at the J.C. Hormel estate, and growing into the picture at the top right here you see.
And Jeff, I'm not sure that we've got your slides advancing. I still see the cover slide.
Okay. Let's see. Do you see that now?
Still the Hormel Institute with the cover picture.
Let's see. Okay. Do you see the slides now?
Yeah, so there we go.
There, okay, sorry.
That's it. Sure. Back to you.
Okay. Oops. So at the top right, you see as the institute looks in its present day, and we have quite a lot of lab space for PIs to come in and use our facility. And quite a lot of lab space. We have about 130 researchers, and we have room to double that in size. And you know, formally we're part of the University of Minnesota's Office of VP Research for our management. So here's a photograph of the Cryo-EM microscope plus some of the research faculty who are using it. It's a Titan Cryo system. There's Nobel Prize-winning technology associated with it, and it's the most advanced microscope for structural biology research. As I was mentioning, you know, electrons aren't getting any smaller, and with this we can get sub 5 angstrom resolution for the microscope. And this is one of the few. It's one of the few instruments in the United States that are active, because it needs a lot of it needs a large facility and a large ecosystem of equipment to operate it. Here's a little diagram that I put together to kind of show you how this works. So most of the equipment for the Cryos microscope is all proprietary. So on the top side, the 10 gigabit network that you see there, the storage formats and the microscope, those are all proprietary, and I don't really have any control over those things. So I'm completely slave to the microscope's operators and the manufacturer of the microscope, Thermo Fisher. On the bottom, so on the top there, everything is connected by a 10 gigabit network. Sorry, apologize for skipping ahead. Everything is connected by a 10 gigabit network, and the storage, the data storage lands on a Microsoft storage platform, and then that data gets copied over to DDN, and that's kind of the part where I take over from the DDN side. On the part of my network that after the data has been handed off over to me, I help the users use that data in an HPC system using the DDN GPFS system, and then once they have finished operating on the data, then the data gets written off or gets archived off to the T950 and BlyPearl. And on that network, we have a 40 gigabit network on that side. One of the things that's a little bit more difficult about the institute is that our uplinks are very low bandwidth. So currently we only have 1 gigabit of network uplink. We're working on upgrading those to a pair of 10s and the new feature, which is still not, by today's standards, it's not a lot, but a few folks have talked about cloud, and cloud just isn't possible when you only got a 1 gigabit uplink. So we really had to look for something that we could bring on premises and deploy. This slide is basically just what I was talking about earlier. To give you a size of the data that's produced, we can produce up to 10 terabytes of data per day. Usually we're not producing that high a rate, but that's sort of an upper limit of what we could produce in a day. More typically, we see data sets in the 2 to 5 or 2 to 10 terabyte data range. And so the DDN file system that we have there is 500 terabytes, and for the HPC analysis that is performed on that data sets, GPUs are actually preferred, and we deploy relatively high speed I/O through GPFS to those HPC systems. And then we also have a lot of users who like to operate interactively on the data, and so those are deployed to local user workstations. And then here's a graph that kind of gives you an idea of the real challenge. This is a data set, a real data set with 7.2 terabytes in size, and the microscope produces, this is all data set, and the format is all set by Thermo Fisher, so I have no control over it. It produces data, and the data lives in 103 directories. There's almost over 35,000 files, and the average file size is just really all over the place, and that's what makes it really hard to manage these data sets. So of course most of the data is in large files that are 1 to 4 gigabytes, but there's a very large component of that data which is in very small files, which you see there in the darker blue shade. And so as I was mentioning, that's a real challenge. The other problems are that the folks when they designed the storage system that they have, the DDN storage system, it was really undersized, and because of that, typically they run the data storage system at 85% or more utilization on the 500 terabytes. I came in last year at the Institute, so I've been there for a year, and they thought I was going to come in and fix all their disk space problems, which is really funny. But of course, I wasn't able to do that, at least with not what they had on site. The other problem that I ran into is, I mean, most of the data is image data, and so it's not very compressible because it's already compressed. And any kind of tools that you use to try and compress that take a really long time to operate on the data. And so, I mean, I had been familiar with the T950 and the Black Pearl technology, and I had brought it to the Minnesota Supercomputing Institute as well. And I was convinced that would be a good solution for the Hormel Institute as well. Of course, we weren't able to leverage any existing infrastructure because of our poor network connectivity. So we acquired our T950 and a Black Pearl in January of last year. Sorry, just one second. Oops. As I was mentioning, we have good internal networking for transferring these kind of files around, but not out of the Institute. And then over 40% of the files are small files, and it's the small files, for Black Pearl, that create a large barrier for transfer efficiency of that data. So I'm just trying to hide this little icon out of the way, and it keeps getting in my way. Let's see, I skipped one. So in looking for solutions for the data, some of the requirements that I identified is having tools that can aggregate and chunk the data, and because large amounts of the data were imaged and not compressible, I was going to use uncompressed data, and then let the hardware systems that are in place compress the data any further that it could be possible. There had to be some sort of manifest for finding the files quickly, and then there's a balance between performance and size. So in the Black Pearl system, there are some limits on how many objects you can have in the system, and of course the transfer efficiency was a big hit if you didn't pick a chunk size which is large enough. I was searching for options that could take advantage of the Black Pearl system, and I started off with a product called Duplicity, which is an open source archive tool. There was a number of native endpoints which were available on Duplicity, but Black Pearl was not one of them. And it was kind of surprisingly, I was not able to find any way to, the Duplicity system is really designed for enterprise type data, and and there was no way to turn off a compression that I could find. So the system was forced to compress the data, and you know, I was spending 3 or 4 times more time compressing the data than it actually took to transfer the data over to Black Pearl. So that became a problem. And the other problem with the Black Pearl is that it requires stub data. So if I got hit by a bus or lost the stub data that was used to track the data, then it could be really challenging for someone to bring it back. You know, after doing these options, I started going back to old standbys, which were you know, tar multi-volume archives, and I decided to use that as the tool to create the data sets that I would then transfer over to Black Pearl. And these formats were nice because I mean, most everybody in the storage industry knows what tar is, so they would know what to do if you know, in terms of business continuity, having these files. So that was less of a concern for me, and also I could really control whatever chunk size I wanted to have in the data, and I set that chunk size to 50 gigabytes per volume. So after you know, after the tar system started tarring the data sets here, a new volume would be created every 50 gigabytes, and then once that was complete, you transfer the whole thing over. And of course, I created a manifest and did some checking to make sure that everything was completely copied over. The 50 gigabyte, I did do some experimenting with that, and I found that it was a good balance between performance and size. It's you know, when you've got 7.2 terabytes, 20 files is equal to a terabyte. So it's kind of easier to track in terms of file count if you want to look at that as a way to make sure you've gotten everything that you asked for. And then Globus. So Globus, I had Globus connected between the DDN mount points and the Black Pearl system, and there I could transfer. You know, if you're Globus would have to be for another talk, but basically, once you start Globus, you can release it. It's kind of like batch transfers for data. Those transfer rates, because we have good internal networks, as I was mentioning, we could exceed 300 megabytes per second, or about 2.5 minutes per 50 gigabyte file, and I could have 3 or 4 streams going at that rate. And just to give you an idea, it took many hours to compress a 50 gigabyte file, and once you had that compression on that file, you would only gain about 20% reduction in the size. So the fact that it took hours to compress, it didn't really you didn't gain anything by transferring the compressed file over the network, because you're transferring a smaller file in the end. The other I did verify that the hardware was compressing it. So there's a media lifecycle management tool that's available in the T950 to see how your tape compression and so on, your utilization is going, and I was able to verify with the MLN that the tape was indeed compressing the data by about 20%. So I didn't really have to do anything, and it didn't cost me any. It didn't cost me any additional time for letting the T950 compress the data. All of our data, we use 2 copies for tape for extra compression, and so far we've transferred over 330 terabytes of data to the systems. In previous years, the Institute, would produce about half a petabyte of data in a year, and there's been some upgrades to the system that make that a little bit faster now. But we are a lot of data folks take and they don't keep because the data quality is more difficult to assure. So I wanted to mention a little bit about economics because that's very important to everyone. So last fall I worked with SpectraLIVE to acquire the initial system, which is described here. So 4 LTO-8 tape drives, the Black Pearl, the T950, and 888 terabytes of uncompressed tape storage. And then I like to, to justify what things cost. I usually have to go through some hoops with our financial folks, and so I doing that's kind of natural to me now. And that came out to be less than $33 per terabyte per year for the system, and then we added additional capacity this past July, LTO tapes. So initially it was LTO-8M tapes, which are slightly lower capacity than the full LTO-8 tapes. We added additional capacity to bring us up to 3.1 petabytes of total data storage, and that dropped the price down to $10 per terabyte per year. And if you're just looking at additional storage cost in terms of that, after you made the initial investment, you're at $1.15 per terabyte per year. And then the 4 tape drives, those are capable up to 750 megabytes per second each, which means if you had everything going full throttle, you could transfer an entire petabyte of data in about 100 hours. And all these prices, they have, they have the right lifetime set in, the depreciation cycles and so on, and also support. So these are numbers that take all that into account. I assume a 5-year lifetime for the Black Pearl and a 15-year lifetime for the T950, and also include yearly support cost. And up in the corner there, you can see a graph from a transfer that I did. It's quite well over 300 megabytes per second transfer rates. And that with that, that's what I wanted to tell you the story about here today at the Hormel Institute. And I can take questions, and also feel free to send anything you want to me as well. I have my email address here. And thanks.
Thank you, Jeff. One question came in, says, just to clarify, by compressing on the tape side, did that eliminate performance issues? So you mentioned you don't get a lot of compression, about 20%, you said, but it's free. Once you pass the compression to the backside with the T950, were there any performance issues anywhere along the line then?
No, so I didn't have any more, any performance issues along with that. At the moment, I think the main bottleneck is in the storage system. So the DDN is exported as an NFS system to the Globus endpoint that we use, and so typically those are limited to about 400 megabytes per second, or maybe 500 megabytes per second on some really high-end systems. So I think that's where the bottleneck is in performance right now. And if we wanted to improve that, then we would make the endpoint available as GPFS, for example, would give us a little bit better bandwidth. But we were kind of 2/3 through the life cycle of the DDN system, and so we are actively looking for different storage platforms to replace that piece, to replace the spinning piece where the data will land and then where the analysis happens.
Right. Okay, great. I think that is it for questions. So thank you again for joining us and giving us that insight. And thanks for the offer of direct contact as well. We appreciate that.
Thank you.